Welcome to Industrial Problem Solving. My name is Dave Roysum. I am super excited to begin a new mini-series on troubleshooting using the most sensitive instrument ever invented, your eyes. Your eyes are about 1,000 times more sensitive than any camera you could ever buy. This series will show you how to improve your visual inspection of webs and rolls to more quickly reduce waste, delay, and customer complaints. In this clip, we begin by training our eyes. In the two clips that follow, we will show how to construct inspection stations on your machine, as well as inspection booths for your test lab. Then we will talk about cameras. I know your time is precious, so let's get started. So, what is seeing? It is simply the art and science of observation. The art comes from being able to notice everything, no matter how small, and no matter how seemingly insignificant a feature might be. Here, we don't know what we are looking for, yet. However, the goal will be to construct a working theory. In logic, this is called deduction. The science comes from looking for something quite specific, related to some working theory you already have. In the science of wrinkling, for example, we might be looking for a wrinkle at an angle to tell us that something is crooked, and then proceed to find out whether it is the web that is crooked or that it is the machine that is crooked. Depending on what they are working on, a good industrial detective will be able to see everything, no matter how small, as well as to see something specific, no matter how small. It is like having bifocals to improve close and far vision. So, what is common for both the top-down and bottom-up approaches? Seeing the smallest and finest of things. At this point, you should be asking, why bother with a series on seeing? The answer is that many internal rejects and most customer complaints are based on seeing, rather than a failure to meet a numerical specification. Probably the best evidence of the importance of seeing is the Rolling Web Defect Encyclopedia. Every defect has a picture. Not a single one has a measurement. Okay, fine. So seeing is important. But wasn't everyone born with eyeballs and know how to use them? The answer is yes to the eyeballs, but not always on the knowing how to use them. Observation skills are seldom taught in school or in the plant. In fact, as we will see shortly, we are often taught to ignore things which are not thought to be big enough to be rejectable. You should also ask why I would be qualified to teach this subject of seeing. Most people know of me as an author because I have published 10 books and hundreds of articles. Or they may think of me as a teacher because I have taught 5,000 students. Yet most of my work has been as a troubleshooter. I have been to 1,000 plants and have seen 10,000 winders and 10,000 wound rolls and 10,000 webs. As a troubleshooter, I act very much like an industrial detective, gathering clues and then forming and testing working theories. In these travels, I have found that paying attention was at least as important than is knowing things. Paying attention is the hardest skill to learn as an engineer because we are expected to know things. not how to see things. However, what most people don't know about me is that I am also an award-winning professional photographer, having taken some 100,000 curated photos in my life. You can find some of my work on my photo website, Facebook, Flickr, and Instagram. Being able to see is the number one asset of a photographer. Nothing here says that you can't also have data, or even that data might not be primary. However, trustworthy data is seldom available for some of our most important web defects, such as wrinkling. Trustworthy data is also seldom available for any of our wound roll defects, such as corrugation, starring, etc. At best, the data, when it is available, is a noisy, binary go, no-go for the entire roll, depending on the mood of a particular QA inspector or customer on a particular day. This will be a short clip, so short that I will only give you 2 lessons. However, these lessons will be the hardest for most of us to learn, and we will never master them. Still, they are the most important lessons upon which much of the rest of this mini course is built. Ready? The number one rule for seeing is to turn off the thinking machine. Thinking and seeing are almost mutually exclusive. Attention to one will mean at least some, if not complete, blindness to the other. For those of you who think that you can think and see at the same time, I have a little experiment for you to do that has been well studied by cognitive psychologists. The next time someone asks you a difficult question, I want you to look directly in their eyes while you are thinking of their response. Most people, after the age of 5, will avert their eyes for at least a few seconds for all but the simplest of the questions. The reason is that merely trying to process your facial expressions while also trying to process a response will put most people into cognitive overload. So again, turn off the thinking machine when you are observing. The number 2 rule for seeing is that your point of reference is geometrically dead flat and geometrically perfectly round, and so on. It is not whether it is too bad, too much, possibly rejectable, and so on. This is where experience is not your friend. You get used to seeing things because that's the way it usually is, and then soon, before you know it, you won't be able to see it anymore. This is like a bad smell that seems to disappear after a few minutes, even in a closed room. Scientists call this olfactory fatigue or olfactory adaptation. The same process happens with our eyes. I teach this vital skill of seeing when troubleshooting wrinkles as just one example from my award-winning and trademarked Web 101 class that has been taken by 5,000 students. Note that our reference is flat as a tabletop or flat as a pane of glass. After teaching students how to look, I teach them where to look and then what to look for. I also teach them how to quantify wrinkles using a mechanics-based metric rather than the worse than worthless pounds of rejects or number of customer complaints. Still, measurements are seldom needed for wrinkle troubleshooting, and our eyes are always the first line of inquiry. However, this clip is not about wrinkles. It is about how to see. Seeing a web that is not dead flat is the beginning of this problem prevention process. Not only do I teach observation in my award-winning Web 101 class, I also teach it in my industrial problem-solving class. This example I use there is that people usually ignore wrinkles that happen at thread speed because they quickly go away when they speed up the machine, and the web just above the core is not used anyway. In other words, the wrinkle was not rejectable because of where it occurred, and thus people no longer pay it any attention. This is the industrial equivalent of a near miss. Vital information was ignored, even when it was initially seen. Thank you so very much for joining me in this problem solving and problem preventing series that is based on observation. Here we have learned two skill sets to work on. The first is to turn off the thinking machine, and the second is to learn how to see the smallest things. In the next clip, we will show how to inspect webs in a machine. We will also show you how to set up an inspection station there. If you found anything interesting or useful here, please consider supporting the work of this channel using the Patreon link below. Patreons are given special thank you gifts ranging from email help to a signed copy of my latest book, the must-have 500-page Web Handling Handbook. See you next time.